Hi, this is Mrs. Vrobel. This is part one of chemical reactions. So as you see on the first slide here, I have a match, and I want to show you, this is an example of a chemical reaction. So what's happening here is you actually have red phosphor, and I'm striking on the side of the box, and this is actually crushed glass, which gives it enough friction so that when you strike it, it interacts with the sulfur and the potassium chlorate that's part of the match. So here is an example of a chemical reaction. Now it's important to remember when we're looking at chemical reactions that we have to remember the conservation of mass. So we can't get a free lunch. It's neither created nor destroyed. So what happens is whatever mass we start with changes into something else, and we have to keep track of all of the masses. Okay, so you may have heard of and you may have seen what we call a chemical reaction or a chemical equation. And always the reacting substances are on the left, the products are on the right. And there's an arrow that typically goes from left to right. Now you may see a situation, just to let you know this is possible, you may see a double arrow. So what that means is the reaction can go to the right or it can go to the left, depending on what you have. The plus symbol tells you you have more than one substance. You may see these symbols at the bottom here. So S is solid, L is liquid, G is gas, and AQ is a water solution. We'll be doing a lot of reactions with water solutions. Okay, so you may begin given a written equation and you have to translate it into the nomenclature or the shorthand that chemists use. So notice here it says aluminum S, so S stands for solid, and you may see L, L stands for liquid, and then the equation would be aluminum and bromine react to produce aluminum bromide. We use what we call skeletal equations. Chemists are lazy, they don't want to necessarily write everything down, and they use the symbols and the formulas. So notice that these are the two reactants. Here's the product. This is essentially solid aluminum reacting with liquid bromine to give us aluminum bromide. Notice I'm not saying aluminum tribromide, okay? This is an ionic compound. We do not use prefixes with it. Okay, why do we do this? We need to keep the conservation of mass. The question is it balanced? It's very important when we're looking at chemical equations whether or not something is balanced. Now notice, if you look at the diagram here, we have one aluminum atom, we have two bromine, and we're ending up with 3. So the question is this a balanced chemical reaction? The answer is no. Now, we're forming the correct substances, but we don't have the correct amounts. So we need to show a balanced equation, and the way we do that is we put what we call coefficients, and they are right in front of the element or compound symbols. So in order to make sure that the mass balances, notice we have 2 aluminum atoms in the reactant side, we have 2 aluminum atoms in the product side. Here we have 3 sets of bromine molecules, or 6 bromine atoms. Here we end up with 6 bromine atoms, 3 in each product. So you have to have a balanced equation in order to have a true chemical reaction. Okay, how do we do it? Well, the first thing is you have to translate words into symbols. So you may be given a chemical formula, or you may be given the written name, and you have to be able to translate both. please, please, please make sure you remember your nomenclature. Ionic compounds are named differently than covalent compounds, so we have to keep both straight. And then lastly, we need to look at coefficients. So coefficients are used in order to balance equations. That means we have to keep track of the same number of atoms on one side as we see on the other. Okay, so here we go. We have a chemical equation where we have natural gas, which is in the formula CH4, burns in air. Whenever you see the term air, just assume they mean oxygen. So even though air is composed of even though air is composed of more than just oxygen, we typically just look at it as oxygen. And notice it's producing carbon dioxide and water. So we're talking about CO2 and H2O. And once we've identified things, we have to conserve. We have to figure out what is the coefficient of each going to be. And in order to do that, we're actually looking at what we call mole ratios. Now let me just show you here. For the chemical equation, if we write CH4 plus O2 yields, or reacts, gives us CO2 plus H2O. The question is, do we have the right number? Here we have one carbon, one carbon. We have 4 hydrogen here. We only have 2 here, so it's not balanced. Same, we have 2 oxygen here. We only have 1 here. Okay, so you have to figure out a way to balance the equation.